Hello, Mario. In this video here, I'm going to be looking at calculating the areas of quite regular shapes. I think the key here in the first instance is to realize that all of these shapes can be broken up into triangles, and then the area can be worked out individually from that. However, generally there are a fair number of shapes that have a name, type of shape, and obviously formula. Now this particular shape here is a parallelogram. So to find the area of a parallel, which is these two lines like that, parallelogram, just a little bit of a abbreviation there, area of a parallelogram, there's a formula for that, and it's essentially base times height. Now it could be expressed in other ways, but essentially this is the base here, 30, and that's going to be meters, because if it's nothing, I always assume it's meters, because we work in a metric country, so that would be 18 meters. So it's base times height. Now, just as it is with the triangle, the height is the perpendicular distance from the base to the other side. Remember, it's the perpendicular distance. So these distances here of the sides are going to be slightly longer than this distance here, the height. And it must be perpendicular, and that's what this little thing here indicates. So in this case here, we've got the base is 30 meters. And I'm going to include the units here, 30 meters, and the height is 18 meters. 18 meters. Now, we know that if we multiply that out, 30 by 18, we're going to get 540. 540. And if we multiply meters by meters, we're going to get meters squared. 540 meters squared. Now in this case here, I haven't shown the accuracy of that. With the calculation and what have you there, it's quite clear what it is. But we could, if we wanted to, show the accuracy there, and the accuracy there would obviously be 3 significant figures. 3 significant figures. Because it's accurate, obviously, to the nearest square metre, and 3 significant figures in that case there. If you wanted to show the accuracy, but I can forgive you if you didn't. Now, let's just have a look here at the next problem. It's pretty similar. It's a parallelogram with a base. I've made it slightly harder because I've got decimal points in there. So there's going to be some issues there with rounding and what have you. And then here's another one here. Again, this is a parallelogram, just slightly different. Now this next one here, let's have a look at this. This is a slightly different shape. A parallelogram has 2 sets of parallel sides. So that side and that side are parallel. Now if we look at this shape here, it has 1 set of parallel sides, and these other 2 here are non-parallel. Now this is in fact a trapezium. So the area of a trapezium area of a trapezium equals, and I'm just going to go over to here to refer to my answers that I have prepared previously, just to make sure that I've got things about right. Now, the area of a trapezium is equal to half the sum of the parallel sides, which we refer to as A plus B. So it's half the sum of the parallel sides times the height. Now you'll notice that I'm not showing the times the height. That's sort of inferred in the way that we write this in terms of the rules of algebra and things. But it's hopefully you're picking up on that it's half times A plus B times H. So we're going to put that in there. So half the sum of the parallel sides times the distance between them. Remembering that the distance between parallel sides is always, the perpendicular distance or the shortest distance, as shown by our little thing here. So the parallel sides are here. That would be considered A, that there would be considered B, and here we have H. Okay, so a half times, and then in the bracket A, which I've identified as 27.39, darken that up a bit, 27.39 plus 37.63, and you would be trying all the time to keep, when you're using your calculators, to keep all of this in the calculator at once. You don't want to be re-keying answers in. So you want to keep everything in the calculator till the very last minute, and then you can actually round it up times 21.95. Just in terms of units, the half would have none, that would have a metre, that would be a metre, and that there would be a metre. Like that. Now, the thing with these is that if you add metres, you're going to get metres. So you know that if you add 27.39 metres to 37.63 metres, if you add them together, and then you find half of that, that's going to be in metres. And then if you multiply that by metres, of course, you're going to get metres squared. I'll just leave a little gap there. And we do that on our calculators. Well, first of all, we can either key it into the calculator and put the brackets in, or I would go 27.39 plus 37.63, and that comes out at 524. So I would do that first, 27.39, 524.9975. Do that addition first, and then I'd multiply that by a half, 9975, 9975, multiply that by a half, and then I'd multiply all of that by 21.95 metres. And I've just got that wrong because I've copied down the wrong number. So I'm just going to undo all of that and actually write in the correct answer, which is, and I've just mucked it up again, as I do from time to time with the, let's go there. Oops, that might be a bit small. There. Okay, and that actually equals 713.5945. 5945, and as I've explained, meters squared. And that will actually be accurate. There won't be any other decimals after that because we're dealing with rational numbers. So we're going to have 2 decimal places there, times 2 decimal places will give us 4. And then we might want to round that off to 2 decimal places, and that would be 713. We're rounding here into the 2nd decimal place there. Just lightly put a little thing in there. So the number we're looking at is the 9. Does it go up 1, in which case that would be 60, or does it stay the same? And in this case it stays the same because we've got 4 or 5 or less in the 3rd position there. So that's like that. Meters squared and to 2 decimal places. And yeah, there you go. 713.59 meters squared, 2 decimal places. We usually put that in brackets, like so. We try and keep the equal signs in a line, like that, all the time. Just gives us a point of reference for our things. Alright, so that's the trapezium there. The next one is a trapezium there, and except that you can see that one of the sides, one of the sides is actually the one of the sides there is also the height. So in this case here, that side there is the height. So we need to just be aware of that. Now, it comes to this last one here. This last one, a little bit trickier. Going to take a bit of a challenge, this one, but what I can say is that, let's make this a little bit narrower there. What I can say is we can divide this up. I'll just put this into like so. We know that this here is what we call a regular 5-sided figure. So we know that regular 5-sided figures have regular angles, and that those angles are the same, obviously, and we know this is regular because we've got the little ticks here that tell us that all of these lengths of these sides here are the same length. So we also know that this angle in here, I'll call it theta, perhaps, for want of a better, that angle there will be the same as at each one of these. And we also know that the 5 times theta, because there'll be 5 angles, we know that 5 times theta, the angle at the center, will equal 360 degrees, because obviously angles at a point at the center. So this one here, and we can see that there's going to be 5 of these triangles, 1, 2, 3, 4, and 5, and each of those triangles is going to have the same area. So all we need to do is work out the area of one of those triangles, and then multiply that by 5, and that will give us the area of the pentagon. So remember, this is a pentagon. So it's quite a challenging little problem, this one, area of a pentagon, because now if we start to look at the triangle, area of a triangle, which I'm hoping you'll remember, the area of a triangle is half the base times the height. But we don't have any heights, remember the height, but we have the base. But we do have another ace up the sleeve, and that is the area of a triangle, can be expressed as 1/2 BC sine A. So that's half the product of two sides times the sine of the angle between them. So I'm going to leave that one with you there. There are a number of options. Don't forget that you could, if you're stuck on this and want a solution, you could try doing a bit of a Google search. I'm sure you'll find a formula and other explanations as to how to do this. But I'm going to leave this one here as a challenge for you. I've given you a few hints. This is the hint number 1, that's the formula that you're going to use. So you're going to use hint number 1 will give you the area of one of these triangles. Hint number 2, so we know that if 5 times theta equals that theta is going to equal, so that's sort of hint number 2, that'll give you the angle there. So there's number 1, that's the formula, and hint number 2 will be the theta, what that will go, which will probably equal A in the formula. And then B and C, of course, are the two sides, which you can see, hopefully, that they're the radius of the circle. So this little video's gone on a little bit, covered a little bit, but hopefully that'll just give you a few hints as to how you might be able to work with this particular worksheet and get it all done. So good luck and cheers!